Welcome to Talk Tensors, where we unpack the latest and most impactful research in machine learning.
Great to be here.
Today, we're diving into a really fascinating paper. It's proposing, well, a brand new way to think about integrating large language models, LLMs, into gamified systems.
Yeah, it's moving beyond the basics, isn't it? Like, forget just points and leaderboards.
Exactly. This is about a fundamental mathematical framework. The idea is to create truly dynamic, personalized engagement using these LLMs.
Absolutely. This paper is tackling a really exciting area, I think. How do we actually use the smarts of LLMs, their language understanding, their generation, to make gamification, work better?
Right. Boost that motivational power.
And the real innovation, as you said, is shifting away from those static, rule-based game elements.
Which can feel a bit predictable sometimes.
Yeah, toward these AI systems that can really adapt, like in real time, to each specific user.
It's interesting because the authors point out, and it seems obvious when you think about it, that gamification works. LLMs are powerful.
We know that. Lots of applications for both.
But putting them together has been mostly, well, conceptual, right? Just ideas floating around.
Exactly. There hasn't been that rigorous foundation.
So this paper really makes a contribution by laying down the math for it and the implications. Well, you start thinking about learning that feels totally custom built.
Or healthcare apps that adjust to how you're doing, what you need.
Even shopping, retail interactions that actually get your preferences and reward them properly.
And for us, on the research side, the big D is this formalized approach.
The math itself?
Yeah, the equations. They've actually developed a mathematical framework modeling key things like user engagement.
How long people stick around.
Right. And how tasks can adapt, get harder or easier based on how you're doing.
And how rewards are optimized within these systems.
It just gives us a much more systematic, data-driven way to design these things, doesn't it?
Yeah.
Moving beyond just intuition.
Okay, so let's get into this framework. The paper starts off highlighting something we sort of know. Gamification works.
Yeah, they cite studies showing it boosts motivation, engagement in business, healthcare, education. It's pretty well established.
Then it pivots to LLMs, naturally. Their advancements, their potential to add intelligence to gamification.
Through things like personalized feedback, adaptive learning.
And generating content on the fly. Imagine an LLM not just giving you a standard question, but maybe crafting a unique problem based on exactly where you messed up last time.
That's the promise. And academically, what's interesting is how they pinpoint that research gap.
Right. Lots on gamification, lots on LLMs.
But not much formally connecting them, especially with a mathematical model.
So the main goal here was to fill that gap, create a formal model integrating LLMs into gamified systems.
With a specific focus on user engagement, adapting tasks, and figuring out the best reward mechanisms.
Okay, so how do they actually approach this? They talk about gamification's track record first.
Right, mentioning things like language learning apps.
Duolingo, things like that.
Yeah, or healthcare apps using challenges and rewards for healthier habits.
Then they stress the power of LLMs for adaptive learning, creating experiences tailored to the individual.
Citing research showing LLMs can improve adaptive learning by adjusting content, providing support based on, specific user needs and performance.
And that real-time adjustment of difficulty, the instant feedback, that's a key strength LLMs bring.
Definitely. And they also touch on the theory behind gamification itself.
Like finding that sweet spot between challenge and engagement.
Exactly, that concept of flow. And they acknowledge existing models for rewards and task sequences.
So laying the groundwork.
Right, showing how their framework builds on what's already known, but specifically adds the LLM capabilities.
So the core contribution, their method is deductive, right? Build the model, test it with simulation, then think about applications.
Correct. And the heart of it is really these three main equations.
Let's break those down. The first one is about user engagement over time.
Yeah, it's a differential equation. Basically, the change in engagement depends on the reward rate versus the disengagement rate.
Like how often you get rewarded versus how quickly you might get bored or frustrated.
Exactly. With coefficients, IDNs, and AGI weighting those factors. Yeah. The idea is this helps predict retention, optimize rewards, kind of understanding the levers you can pull.
Okay, makes sense. What's the second equation?
That one's for task adaptation. It adjusts the task difficulty T for the next step.
Based on how well the user did this time.
Right. Based on the user's performance, UT, compared to some desired success rate,
yes.
CNA, and there's a parameter guy controlling how fast it adapts.
So it tries to keep things challenging, but not like impossible?
Precisely. Maintaining that optimal challenge, like a self-adjusting difficulty slider.
And the third one, that's rewards.
Reward optimization, yeah. RAT. It calculates the reward for an action by balancing the potential long-term gain, GA, against the immediate cost, CAD.
With weights, W1 and W2, to tune the balance.
Exactly. It's a mathematical way to figure out the best incentives for the behaviors you want to encourage.
And they also mentioned reinforcement learning, Q learning.
Just briefly, yeah. Using Q learning to help the system learn better responses over time to improve user satisfaction and engagement. It's another layer of optimization.
It's really interesting how they're trying to, well, quantify these things, engagement, motivation, that often feel quite qualitative.
That's the key research aspect, I think. Putting it into equations gives us tools for more rigorous design and analysis when we bring LLMs into the mix.
So they built the model, then they tested it with a simulation.
Right. They set up a simulation, defined different user profiles. Some get engaged easily, some less so.
Okay.
Then they simulated task difficulty changing based on performance using their equation. And they plugged in a reinforcement learning algorithm to optimize the system's responses within that simulation.
And what did they find? Did it work?
The results, which they show in some charts, were pretty compelling. They found, for instance, that a higher reward coefficient, that alpha value, led to faster engagement growth.
Makes sense. More rewards, people get hooked faster.
And a higher disengagement coefficient, beta, meant engagement dropped off more quickly if things went wrong.
Also logical.
And that adaptation rate, gamma, affected how much the task difficulty jumped around.
Okay.
But importantly, the simulation suggested the framework did work. It maintained engagement, maximized rewards for the simulated users, and adjusted tasks in real time with the LLM component.
Leading to better retention and success in the simulation.
Exactly. The graphs showing engagement over time had this nice pattern. Initial rise from rewards, some wiggles as difficulty adapted, then stabilizing.
Showing the system could adapt and find a balance.
Yeah, and the task difficulty graphs showed it adjusting based on performance, avoiding getting stuck being too easy or too hard.
Which, again, links back to that flow idea, right? Keeping people in the zone.
Precisely. Too hard, you get frustrated. Too easy, you get bored. The LLM-driven adaptation helps maintain that balance.
Did they look at changing the parameters, like alpha, beta, gamma?
They did. The simulation showed the system was sensitive to these settings, which is actually a good thing.
Why is that?
It means you could potentially tune these parameters, adjust the weighting for rewards, or how fast difficulty changes to customize the experience for different situations or even different types of users.
Ah, okay. So the simulation supports the theory. What about the real world? Where could this actually be used?
Well, this is where it gets really exciting. They explored applications across several industries.
Like education.
Definitely. Imagine adaptive learning platforms where the LLM gives instant feedback and generates personalized practice problems based on exactly what a student is struggling with.
Like a dynamic tutor that creates examples just for you.
Right. Could potentially improve learning outcomes, maybe even reduce dropout rates.
What about healthcare?
Personalized wellness programs. Think AI-generated advice or challenges that adapt to your fitness level, your progress, maybe even your motivation levels that day.
Could help people stick to their health goals better.
That's the idea. Then there's retail.
Loyalty programs.
But much smarter. AI-driven programs based on a deep understanding of your actual shopping behavior, offering personalized rewards that really resonate.
Beyond just buy 10, get one free.
Way beyond. Also, corporate training scenario-based simulations where the difficulty ramps up dynamically as the employee demonstrates mastery.
For things like customer service training.
Perfect example. And even entertainment interactive stories where the LLM changes the plot based on your choices.
Making it much more engaging.
The common thread is that generative AI enabling real-time adjustments, tailored feedback, dynamic content. That's what makes these applications possible.
So in their discussion, they kind of loop back, right? Saying the framework bridges engagement and adaptability.
Yeah, they reiterate that potential across education, healthcare, retail.
Yeah.
And they highlight their contribution moving beyond qualitative ideas to actual quantitative models for engagement and adaptation in AI gamification.
Did they mention any limitations, challenges?
Oh, yeah, definitely. They acknowledge the computational demands running sophisticated LLMs for potentially many users could be intensive.
Might need optimized systems or maybe hybrid approaches.
Exactly. Also, data privacy is a big one. These personalized strategies rely on user data.
Need to be careful there.
And potential biases in the AI-generated content. That's always a concern with LLMs. They note these need future study.
Fair enough. Any other future directions mentioned?
developing lighter LLM architectures, improving interpretability, understanding why the AI makes certain decisions.
Okay, so the conclusion wraps it all up.
Pretty much. Summarizes the achievement, the mathematical framework, highlights the simulation validation, how real-time adjustments create better experiences.
Emphasizes balancing challenge and reward for motivation.
Right. Mentions the flexibility from the adjustable parameters, revisits the applications.
And points towards future research, more complex user behaviors, other ML techniques, broader applications. They sound pretty optimistic about the potential.
They do. They end by suggesting LLM-enhanced gamification could really revolutionize how businesses engage users, leading to more responsive, adaptive systems for long-term behavioral change.
They even mention upcoming work on a real-world case study in EdTech.
Yeah, so they're planning to take it beyond the simulation.
It's helpful maybe to put this in a bit of historical context, too. Gamification itself isn't new, obviously.
Not at all. It's evolved from, very simple reward systems, gold stars, loyalty points to much more sophisticated psychological frameworks.
And at the same time, we've had this explosion in AI, specifically LLMs, getting incredibly good at language.
Right. And the limitations of the older rule-based gamification became clearer. Lack of personalization, static content, it often felt a bit clunky.
Creates a need for something smarter, more adaptive.
Exactly, which is where this paper comes in. It's a big step towards addressing those limits by formally integrating LLM smarts into the gamification design process using math.
So if we boil it down, the key takeaways for listeners are, first, the big innovation is the math. Formalizing the LLM integration allows for actual analysis and optimization.
Yeah, it's not just hand-wavy ideas. Second, LLMs enable personalization and adaptivity on a whole new level, things that just weren't really feasible before.
Third, the simulation provides real evidence that this framework actually works, at least in a simulated environment, for engagement and difficulty adjustment.
And fourth, it's got broad applicability, education, health, retail, suggesting it's a fundamental advance.
But fifth, there are challenges, right? Ethics, privacy, computational cost. Those need more work.
Absolutely. Those are crucial considerations for real-world deployment.
Thinking about the implications, imagine educational tools that literally build a learning path just for you, moment by moment, based on how you're doing, using these equations in the background.
Could really change learning outcomes. Or fitness apps giving you personalized motivational nudges generated by an LLM, adapting not just to your steps, but maybe even how you're feeling that day, inferred from your interactions.
Better sticking power for health goals.
And loyalty programs going way beyond points, offering experiences or rewards that an LLM figures out are actually relevant to you right now, fostering real engagement.
Okay, let's shift gears slightly to our novel notions segment. Where could this research go next? I have a thought. What about adding affect, like user emotions, into the mix?
Effective computing. Interesting.
But how
would you see that fitting into their framework?
Well, take their user engagement equation. It has that disengagement coefficient beta, right? What if beta wasn't fixed, but could change dynamically based on real-time sentiment analysis? If the system detects the user is getting frustrated, maybe through their typed input or clicks.
So if frustration goes up, the effective beta increases, signaling a higher risk of disengagement.
Exactly. And that could trigger the LLM to intervene proactively, offer help, simplify the task, suggest a break. Something tailored to that detected frustration.
So the system responds not just to performance, but to the user's emotional state, trying to head off frustration before it causes someone to quit.
Yeah. Think about learning again. A student struggling writes, "This is impossible." The system detects that negative sentiment.
And the LLM jumps in with maybe a simpler explanation or a different kind of problem targeting the same skill.
It builds right on their framework and the LLM's personalization power, but adds that emotional intelligence layer. Could it make systems feel much more supportive, maybe even empathetic?
It definitely opens up research questions. How accurate is the sentiment analysis? How do you best integrate that signal into the equations? But yeah, the potential for more user-centric adaptive systems is huge.
Okay, another idea. What about the data privacy issue they mentioned? Federated learning.
Using federated learning to train the LLMs and maybe optimize those parameters, alpha, beta, gamma, the weights, across lots of users, without centralizing their raw data.
Yeah, so individual apps or systems fine-tune their models locally based on their own users.
And then only share like anonymized aggregated updates back to a central server to improve the overall model.
Exactly. It directly tackles that privacy limitation they flagged. You could get the benefits of large-scale learning and personalization.
Without compromising individual user confidentiality. That could be really important for sensitive areas like healthcare or education technology.
Imagine school districts improving learning models based on aggregated, anonymized interaction patterns across thousands of students, but keeping each student's individual data completely private on their local device or school server.
That definitely connects the technical challenge of privacy with the potential for broad, responsible application. A very interesting direction.
So wrapping things up then, this paper really does represent a significant step forward, doesn't it?
I think so. Providing this mathematical framework for weaving LLMs into gamification is a big deal. It paves the way for systems that are way more personalized, adaptive, and hopefully more effective.
And understanding this framework gives anyone interested in user engagement, AI, game design, some really valuable insights into where things are heading.
It's a powerful combination of AI and gamified design principles.
And you have to wonder, as LLMs get even better and we learn more about motivation, how will these kinds of AI-powered gamified systems fundamentally change how we interact with technology, maybe even how we pursue our goals in everyday life?
It's a fascinating question for the future.
Definitely something to think about. For listeners who want to delve deeper, the link to the paper itself is available below.
Thanks for tuning in to Talk Tensors.